I do want to just make a mention of the vaccines before we go on to more specific schools, because I think that we have not touted the effectiveness of the vaccines enough. And so I always like to just stray and give a little moment on the COVID-19 vaccines. So remember that we have these three that we've heard about a lot in the United States: Moderna, Pfizer, Johnson & Johnson. But there are actually 9 vaccines out there for COVID-19. And 2 I want to point out to you because they could be coming here as well. And I think that could be helpful for some parents who are still hesitant about the other vaccines, even though the other vaccines are great. But I wanted to tell you a little bit about the vaccines. The Moderna and the Pfizer vaccine, of course, are the mRNA vaccines. Yes. Actually, I just looked at the chat to just confirm that I'm paying attention to what you are all saying. And yes, I will drop all of those references. So the Moderna and the Pfizer vaccine are mRNA vaccines, you know that. And then the Johnson & Johnson, AstraZeneca, and the Sputnik 5 vaccine are what are called DNA vaccines, but they're surrounded by a benign virus called adenovirus. But they all essentially do the same thing, which I'll explain. And they all involve coding for the spike protein of the virus. And the spike protein of the virus is this right here, but it sticks out from the cell and from the virus, and sticks out and combine, and essentially this is how it binds to the host cell. And so the first 6 vaccines on this list somehow involve coding for the spike protein. You code for the spike protein by getting a piece of genetic material, mRNA or DNA. You take that mRNA or DNA, you make it into protein using your host enzymes, and then that DNA and mRNA gets degraded, and then you take that spike protein that's been produced and raise an immune response against it. And then the last 3 vaccines on this list are what are called whole inactivated Varion vaccines. And they're actually more traditional in the sense that we're used to, for example, taking a whole virus, killing it in some way, and then injecting it as a vaccine. And none of these 3 are approved in the United States. And actually Sinovac and Sinopharm are not as effective. They don't have a very good what's called adjuvant to bring them into the human body. This last product, which is called Covaxin, and it's been taken over by something called a company called Ocugen in the United States, is actually very effective. And they did apply for FDA authorization of their vaccine down to the age of 2 on November 5th. And unfortunately, the FDA hasn't looked at it. And I'll talk about that when I get to child vaccines, but I wish the FDA would look at it, because right now we are lacking a vaccine in this country for children under 5. So to explain these vaccines and how they work a little bit better, the final vaccine I want to tell you about that involves the spike protein is the Novavax vaccine. And that's also a more traditional design. It's actually the protein, the spike protein itself, combined with an adjuvant, as opposed to you coding for the spike protein like you do with the mRNA or the DNA vaccines. That's more traditional. We often give proteins: diphtheria, pertussis, tetanus. Those are all protein-based vaccines. And that company filed for authorization on January 31st. And the reason that this could be important is in our vaccine there is vaccine hesitancy, and for children, there may be parents who are interested in a more traditional design. So I do encourage actually the United States, and I've done that publicly, to authorize both Novavax and Covaxin because of the hesitancy that we have in our populations. Now, what all the vaccines do, all of them, whether they're spike protein vaccines or whole inactivated virions, is they raise 2 types of cells, and they raise T cells and B cells, which are the cellular immune response that really fight disease for a long time. And the problem with how the media covers vaccine effectiveness is they equate antibodies with immunity, but antibodies are just one arm of the immune response. So what antibodies do is that they are raised by a vaccine, but so are T cells, so are B cells. Antibodies will naturally come down with time. It's just completely normal, natural, because we can't keep all those proteins in our body. They come down, say, after a booster shot, maybe in 4 months. That's what the CDC reported last Friday after the 3rd booster shot. But the T cells and B cells are produced by the vaccines. We have good data that they're produced by the vaccines. and they will stay around. And what T cells do is they protect you against severe disease. And what B cells do are they're the recipe book to make new antibodies in the future if you see the virus again. So if you are younger and immunocompetent, you likely will say we get another variant in the future. You should be able to take your B cells that you produce from the vaccines and produce antibodies that are directed against that variant. That's called adaptive immunity. And it's pretty amazing data to show that the B cells adapt their antibodies against the variant they see. They see Delta, they'll adapt it towards Delta. And the reason is because adaptive immunity means that your immune system is smart enough to form the antibodies they need to form against what they see in front of them. So this is very busy, no point in going over all this, but it really is to show you that T cells by column 4 were raised by all the vaccines. And then later studies showed that B cells were raised by the vaccines by doing lymph node biopsies and seeing germinal centers form. And T cells protect us against severe disease. So that's column 6, but in all the clinical trials, the rate of protection against severe disease was almost 100% clinical trials for all the vaccines. And that was true of the 3 whole inactivated variants as well. And so vaccines do work. They work against variants. They work against severe disease because of our cellular immunity. But because our antibodies go down, unfortunately, they don't work to prevent all infections, meaning more mild infections, because the antibodies work more locally in the nose. So during surges, they haven't worked to prevent all what we call symptomatic breakthroughs. And then there are people who are more at risk for severe breakthroughs if they don't have that strong antibody response right away. And those are people who are living with immunocompromised or older people with comorbidities. And I'll tell you about a CDC paper around that.